Hello, wonderful people of the internet. Welcome back to another episode of Leos Labs. I hope everyone's having a wonderful day, and anyone who might be lurking in chat, hey, thanks for being here. So, let me go ahead and update you guys on what we've done since yesterday. Open up a new terminal, Zernal PP, and let's just see what we got. All right, so there's actually a lot of things that we've been talking about, all kind of together. So, we talked about, a few days ago, we talked about ASCII art. Right, which led into a discussion on photo mosaics, which is basically a type of photo that is generated from a whole bunch of other, smaller photos. So it's a photo of photos, right? Both of these were useful for our overall discussion on fractal compression. But in order to generate all of this kind of stuff, we needed, one second, a slight discussion on color quantization. After jumping into the color quantization literature, we realized, hey, wait a minute, this is actually way more complicated than we thought it was going to be. And so we started talking about another similar problem, which was the Barnes-Hutt simulator, which is essentially a way for us to do higher dimensional, or a way for us to do galaxy simulators using the same method as color quantization. Yeah, that's kind of where we left off yesterday. I spent some time looking into the literature, trying to see if we can do a simple n-body simulation. Again, this is specifically n-body. We're not doing we're not trying to keep this incredibly physically accurate. We're just trying to create disk-like galaxies using simple Newtonian physics. We're not going incredibly deep into this, right? Now, all of this is useful for a bunch of other research projects that we have under wraps, but I do want to focus on, one second, let me get out these two guys together, right? So I mentioned yesterday, that presumably, and I've spoken to Grant about this as well, we both kind of want to do some sort of collaboration in the area of 4D galaxies or something like that. Now, I personally am not comfortable making videos on content that's incredibly technical. The reason is that even though I know the technical stuff and I do the technical stuff, I personally feel that when it comes to YouTube videos, that's just not the type of video that I enjoy making, nor is it the type of video I enjoy watching. It's not for me, right? So even though we could talk about a whole bunch of technical details here, I think probably the better idea is to talk about related topics. And of course, the related topic here is color quantization. Now, let's see if I can make that Q a bit more Q-y, shall we? Quantization. Okay, now, there's actually a bunch of similarities between these problems. From what I've seen in the literature, again, just looking at it last night and again this morning, we found that the color quantization literature is better at splitting up spatial systems and stuff like that, whereas a 4D galaxy simulation is better at dealing with adaptive mesh refinement, i.e. Moving forward with time. And so this could be a situation where the two fields talk to each other pretty nicely. We can create better video codecs for color quantization, and we can create some better 4D galaxy schemes or spatial distribution schemes for higher dimensional galaxies. Hey Gibbous, how are you? I hope you're having a great day. Let me also check over here on my notifications screen. Right. So we'll see how it goes. Again, we've had some quiet streams for the past few days. But yeah, we're just going to keep going and see how everything goes for the next few days. Okay. So I actually want to start today off with something a bit different than what we normally do. Let me go over here. That'll work. And that is, I actually wanted to go to the archive. I usually do this on my own, but I decided, hey, maybe today, instead of going to the archive, and looking at all the papers, off of stream in the morning, maybe I could just do it on stream and we could talk about some of the papers that have come out today and why it's interesting for people to keep this kind of stuff in mind. Personally, I really, really love papers, guys, just a lot. And I really want to show people why this kind of stuff is exciting. And I think maybe doing a quick, 20-minute look at what archive papers are available today is a good way to kind of show off different research that's going on in the area. Today is also going to be a literature review stream. Mainly, I'm still looking for the appropriate papers that we need to move forward with this project. So we'll see where we need to go. I've got a feeling it's going to be... I don't know. I've got a feeling that today we're still going to be looking for papers, but hopefully by the end of this week, which is, today's the end of this week, we can start working on more research related problems and stuff. Okay, so I went ahead and opened up the computer science research repository, computing research repository. Here, core is what it's called on the archive. And I'm just gonna kind of look through them and see if there's anything that's particularly interesting about any of these papers. Usually when I get here, look, there's a lot of papers here, right? Like a lot of papers. It's kind of, you don't usually look at all of them. Let's see. So usually, I just kind of look at the titles and see which ones are the most interesting and click on those, and we can go from there. Okay, so first, transformation of node to knowledge. Graph embeddings for faster link prediction in social networks. So for me, this one's not particularly entertaining or interesting because I just don't really care about the node to knowledge stuff, graph embeddings. But when they start talking about social networks, now it becomes maybe a bit more interesting for other reasons. Might be a paper to keep in mind for later. So you have stream sampling with immediate decision. I'm actually interested to see what this is because when we talked about approximate counting and stuff, a lot of the approximate counting algorithms build into streaming algorithms and methods like that. So I'm interested to see what they have here. Let's see, what else do we have? I can delete this tab. A graph autoencoder time series approach towards battery parameter estimation. I didn't realize that was an unsolved problem. I thought that we kind of had a better understanding of how to tell how much power was left in a battery. I thought this was something that people already knew how to do relatively well. It's interesting that's appearing at all. Temporally consistent online depth estimation in dynamic scenes. Interesting. So my question here is, so online depth estimation in dynamic scenes. So this should be a computer graphics, computer vision, and pattern recognition. Okay, cool. Let me take a look at the PDF here, actually. Sure, that'll work. And I think I need to just do ocular. And let's do downloads to 111.93. You got here. Unsolved problems are always the darndest things. Yeah, right? So temporally consistent online depth estimation in dynamic scenes. This is kind of interesting. So, I zoomed in too much. But let me take a look up here. So what are they doing exactly? So we've got, look, it's computer vision, right? But yeah, so it's probably not interesting for the stuff that I usually look at, but I think it's quite interesting that, my favorite thing about looking at the archive is that you find all these little problems that it's interesting as to why people haven't solved them yet. It's hey, what's going on here? Why is this, so this is kind of interesting. I quite like the idea of this paper. I'm not sure if it, how deep it'll go. I just deleted my, that was an accident. I double clicked on the X button. Okay, let me go here, go to the archive again. Archive.org, CS new should do it, and open up that one tab that we had. This one was interesting. There. My favorite unsolved problem from linguistics, are words even real when you get down to it? Maybe, I have no idea. What do colors and galaxies have in common? They sometimes show up in a wheel. Do they? Maybe, I don't know. Yeah, so we talked about this the other day. So it fundamentally comes down to how, what algorithms you use to solve both of these problems. So color quantization and galaxy simulation both use an octree grid. It ends up being that spatial distribution, the splitting up in space, is actually a relatively difficult problem to do appropriately. Now, there are other ways to do color quantization. And my question is, if we implement those newer color quantization methods into the physics literature, has that been done before, and will it be faster? Those are kind of the questions I want to tackle today. I did want to spend some time, though, just looking at the archive, seeing what we have. I'm personally leaning on the side that words are an abstraction that doesn't necessarily exist at all times in every language. So I personally feel, it depends on what you mean by are words really real, but I always feel when you're thinking, right, I only learned this recently, but when I think, words don't appear in my brain. Right? Which is why I have to vocalize a lot of the words that are coming out, right? So if I'm trying to think through something, a lot of times, specifically if I'm trying to think through how I'm going to tell something to someone, I have to actually vocalize it because the words are not words in my head, right? It's just a jumble of different thoughts that then become words when they come out of my mouth, right? I don't really have this thinking about what you need to say because honestly, I don't have this concept of a word in my head. Does that make sense? Like there's not like an internal dialogue going on in my head. But I learned recently that a lot of people do actually have an internal dialogue. It's not just a jumble of like expressions and thoughts and stuff like that. So I think that this question of, are words even real? I mean, like, I don't know what you mean by even real, but I feel like it really does depend on the person and how they interpret the world, Correct formulation of the question is there a consistent definition of word that is well-defined and consistent across all languages? Well, in that case, maybe, I don't know. Strong L2 convergence of time Euler schemes for stochastic 3D, Brinkman, Faulkner, Navier-Stokes equations. I don't actually, so this might be useful because we're going to do some Euler method stuff soon. The People Speech, a large-scale diverse English speech recognition database for commercial usage. Okay, that's interesting. Glad to see that exists. Case study of COVID-2 transmission, risk assessment in indoor environments using cloud computing resources. Okay. Punyu 1, soft tactile sensing upper body robot for large object manipulation and physical human interaction. Wait a minute. Is this literally just like a robot? Like, wait. I have to look at this one. Okay, we'll look at it in a second. So, personalized federated learning through local memorization. What is federated learning? Exponentially fitted methods that preserve conservation laws. Not so interested in that one. Bigfoot exploiting and mitigating leakage and encrypted write-ahead logs. Hypercontractivity on high-dimensional expanders. Oh, that's interesting. This isn't so much about a question like brain linguistics or whatever the field is called. It's more on the level of when Kanye says, I'm going to let you finish, to Taylor, which and how many words did he really use? Oh, I see. Interesting. Optimal decremental connectivity of non-sparse graphs. It could be interesting. See, the problem with the archive is every single time I go to the archive, I find like an abundant number of papers that I want to read. And I'm like, I can't read all of them. There's too much interesting stuff going on. So it's like this one right here, optimal decremental connectivity in non-sparse graphs. I'm like, actually, this could be quite cool. But I know it's going to take me a long time to get through. I probably can't get through it today. And I know for a fact that, like, honestly, it's not going to be useful for my immediate research, so I kind of skip over it. But like, if I had time, yeah, I'd definitely read this, Masked pyramid fusion, 60 pose estimation. Why do you have to do 6 dimensions for a masked pyramid fusion? I don't know. Let's take a look. Hybrid feedback for autonomous navigation in environments with arbitrary convex obstacles. Again, that's interesting, but I think this is going to be mainly, it is robotics, but I feel this is going to be mainly machine learning, although the fact that there is no ML in the subjects leads me to believe that maybe it's just another like PID control scheme. Medcauda, a medically accurate, emotive, diverse, and controllable dialogue system. Okay, could be interesting for certain groups. Combining trajectory data with energy functions for improving region of attraction estimation. So when they talk about attraction estimation, I think they're again talking about like PID controllers and stuff like that. Deep currents, learning implicit representations of shapes with boundaries. Okay, now here's the thing. There is like one of those problems that I keep coming back to, like literally all the time. And that problem is convex hull optimizations, like figuring out the optimal boundary for a set of points. It's actually quite like, I don't know, it's one of those problems that I always find myself coming back to for some reason or another. And this here is like, man, I'm torn, because when I see people using machine learning to solve this problem, I'm like, okay, fine. I knew we were going to get here. I knew people were going to use machine learning for this topic, but like, it makes me a bit sad, because I'm like, man, we were so close to having some good algorithms here. There's a gradient from red ball to physics professor to mobile phone to isn't to mailbox to GPU. Wait, what do you mean gradient? Yeah, actually, could you go into depth about what you mean with that comment, because I might not understand. So monitoring over long-term, intermittent deployment and sensing strategies for multi-robot teams. Man, lots of robotics today. Submodular optimization for a couple task allocation and intermittent deployment problems. Minimum Bayes risk decoding with neural metrics of translation, quality, low precision decentralization, decentralized distributed training with heterogeneous data. Now, the heterogeneous data here could be quite interesting, but I don't really want to do training right now. It's not something I'm interested in. Enforcing safety under actuator attacks through input filtering. What is an actuator attack? Should I know that? All of those are combinations of other words, but some of those words are just one word, and which ones depend on what you're asking, on who you're asking. Yeah, that's fair. I've used Flux. I've not used Flux. However, I have I will probably be using Flux in the near-ish future. That is to say, I've got some projects that probably have Flux. It's probably on the radar of things that I'm going to be using soon. So let's see, what do we have here? Rethinking drone-based search and rescue with aerial person detection. This could be interesting, right? So the question is, if you could replace all of the helicopters searching for people over a forest with drones, I mean, obviously that would be better, right? Like if you could possibly do that type of thing. That's actually quite cool from a just utility standpoint, But this is the thing. This is why I'm always hesitant to look into machine learning applications and stuff, because every time I look into machine learning applications, it's always just that. It's always an application of machine learning to a new field, and it doesn't feel like you're actually learning anything. It feels like, here's machine learning in a new area that it hasn't been before. And it's I get this is what a lot of research is nowadays, but I just don't like seeing it all over the place. I kind of want to see machine learning growing. Not the applications of machine learning growing. You know what I mean? Anyway, I don't know if I'm explaining that properly. Edge ML towards network accelerated federated learning over wireless edge. Multi-sided matching for association of space, air, ground integrated systems. Meta reinforcement learning via buffering graph signatures for live video streaming events. Mixed dual hop IRS assisted FSORF communication systems with HARQ protocols. Automated PII extraction from social media for raising privacy awareness, a deep transfer learning approach, highly accurate and reliable wireless network slicing in fifth generation networks. I'm going to start going a bit faster through these, just kind of going through and see what we have. Blind calibration of air quality wireless sensor networks using deep neural networks. Impact of weather condition on 5D communication channels under connected vehicle frameworks. This is interesting, although I don't know if I would learn much from this paper. It's interesting to know that is something that people are looking into. Distributed proximal policy optimization for contention-based spectrum access. This is the first paper on the list that I actually don't know what they're talking about. Distributed proximal policy optimization for contention-based spectrum access. What are they talking about? I'm interested in this one just because, I actually don't know what's going on. Okay, low to zero overhead IRS reconfiguration, living labs for end-to-end data infrastructure, design and scalable 4G, quality-aware deep reinforcement learning, novel concept for organic transistors. That could be interesting, but again, it's one of those papers that if I had all the time in the world, I would definitely read, but I definitely don't have all the time in the world, On the effectiveness of iterative learning control. Again, another one that is actually quite interesting, but I don't have time to read. Cryogenic memory technologies. What does that mean? Sustainable artificial intelligence through continual learning, monitoring COVID-19, hyperconnectivity, and high-dimensional expanders. Again, this is one that we saw earlier. It's quite interesting. I want to look into it. To an open ecosystem for federated learning mobile apps, L4 weighted adjustment, local mutual exclusion for dynamic anonymous bounded memory message passing system. Okay, so this could be interesting because it's in distributed parallel and cluster computing. I'm wondering, I want to look at the abstract in full, and then we can go from there. Proximal policy optimization is a method of reinforcement learning. Okay, that's why. See, here's the thing. As much as I kind of, say that I don't particularly like the machine learning papers, I think it's because I only see machine learning as a cameo in other fields. Like when you're reading physics papers and you're like, wow, this is going to be super cool. And then they end up just using machine learning for it. Or specifically with computer graphics, you end up finding all these neat algorithms for photomosaic generation or I don't know, density rendering, voxel generation, all this kind of stuff. And then all of a sudden you see at the end, it's but we just use machine learning for this. It kind of takes the fun out of the paper. It's still a good paper, but it's okay, if there's a common trope in anime, how, you've got a single guy and there's 10 girls or something that are all after this one guy, it's one of those tropes, And right now, machine learning to me feels like a trope that you see in a bunch of other literature that really just waters down the effectiveness of the fields themselves. It just feels like as you're reading the paper, if all of a sudden they say, here's a reinforcement learning approach, here's a neural network method, here's deep convex learning optimization schemes, I'm okay, but could we just not for just a second? Could we maybe not just use machine learning everywhere and think of actual methods here? I mean, look, I know machine learning is an actual method. I know I'm kind of dunking on it too hard here because quite frankly, as I said before, I actually don't know much about machine learning. It's just every time I see it, it makes the paper just not as interesting, that's the trope you pick, since I'm currently playing an idle game of that theme. Machine learning is the digestion of very hungry vector machines. In some sense, yeah. I mean, like, yeah. The thing is, I just get disappointed when I see machine learning. That's my point. It's not that machine learning is bad. It's just that when you're reading a paper, you pick the paper because you're hoping for X, Y, or Z. You're hoping for something in the paper. And then when the paper is just like, oh, it's an application of machine learning, you're like, dag nabbit, why? It's like in the end of the anime. It's always like, the real treasure is a friendship you got along the way. It's like, you're reading a paper. It's like, oh, the real research is the machine learning that you found along the way. It's like that type of thing. It's like, why is everything machine learning now? And I realize it's a trope. In the next few years, it's going to be something else, but it gets me sometimes. See, eye to eye, a LiDAR-agnostic 3D detection framework for unsupervised multi-target domain adaptation. LiDAR here could be interesting, actually. Let's see, machine learning is the new, so we checked every possibility on a computer. Yeah, something like that. The thing is that a sufficiently large complex neural network can be trained to do a lot of things and do them very well, but it gives you no insight onto how the problem is actually solved. Right. So, like, for example, my wife is a wonderful physics researcher, and it's great. She's super good at what she does. And I was talking to her recently about, the applications of machine learning in physics. And I just feel like machine learning is kind of antithetical to what physics research is. The point in physics research, in a sense, is to create a model that appropriately depicts the world around you. And by abstracting that away into a neural network, specifically a deep neural network, might give you good results, but it doesn't give you that deep understanding that physicists are looking for. More than that, using a neural network for the stuff that you have to do with physics is kind of like not exactly what the neural network is really good at doing in the first place. I mean, sure, there are methods that work, blah, 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 but it's like, I don't know, it's like one of those big wow moments where you're like, wow, but why though, type of thing with physics, Again, deep learning, vocabulary object detection with human-provided bounding boxes. That one's interesting. Robert Tuito, a pre-trained language model for social media text in Spanish. Feedback strategies for hypersonic pursuit of ground evader. That one's one that I bet, Destin from Smarter Every Day would like. There's a lot of these kind of like chasing models and stuff like that I've never really gotten into. But maybe I should, Okay, improved rates for derivative-free play in convex games. I'm going to ask a stupid question here, something I really should know. So here's the thing. Game theory is something I've never delved into. Is this another topic I should be delving into? Something I should be learning more about? Advanced COVID-19 diagnosis with privacy-preserving collaboration in artificial intelligence. Self-attending task-generative adversarial network for realistic satellite image creation. Grid-forming voltage control strategy for supplying unbalanced microgrid loads using inverter-based resources. Maybe that could be interesting. I like the grid forming voltage control strategy. In fact, this could be quite interesting. There's another project I was thinking about doing recently, which was basically applying a, how do I put this? Applying a, what's called a Newton, is it a Newton square? I think it's called a Newton square. It's like basically Sudoku, but applying that to solving a kind of an outstanding problem in electrical engineering, which is sending internet signals across electrical grids, essentially using a single wire for both internet connectivity and the actual electricity that you use in your home. It's something that people have been interested in the electrical engineering sphere for a while. And one of the big problems there is error correction. And by using, I think it's called a Newton square, I need to look it up, but you can actually use this type of thing for better error correction along these lines and stuff. So it's something that I was thinking about looking into. Contrast and multi-view coding for enzyme substrate interaction protection. Oh man. Okay. Like anytime I see enzyme stuff, I'm like, this could be quite cool, or it could not be, Oh, Tufts though. Interesting. And Google research. Interesting. Okay, but then you see machine learning, I'm like, maybe not. So three-dimensional topology optimization of heat exchangers with the level set method. I know the level set method, so I feel like this should be relatively, or I should know the level set method. Maybe I've forgotten it, but this should be relatively straightforward to get through. Transmission of power policies for energy-efficient wireless control of nonlinear systems. See, here's the thing. We see these power systems appear quite regularly in the literature. It's actually kind of interesting, right? Lifelong reinforcement learning with temporal logic formulas and reward machines. You know what I want to do? I want to create a YouTube for archive papers. That's what I want to do. I want to have like a YouTube algorithm that just kind of like, you'll go in here and you you click on papers and stuff like that, and then it kind of like gives you what you want. It kind of gives you a like a recommendation for what you want to read based on, what other people are reading in the field and stuff like that. I think that'd be super cool. Interactive machine learning, need for additional representation layer. Yeah, this is where I should learn more about this topic, but I don't know that much about it. So you want the archive to have even more machine learning on it? Well, to be fair, it wouldn't be so much machine learning as it would probably be simple clustering schemes, which I suppose is, in a sense, a type of machine learning. But usually, like, I would probably use some sort of like affinity propagation scheme or something like that is what I would do. Now, is affinity propagation machine learning? I don't know. Is it? Affinity propagation is a clustering algorithm, just a basic clustering algorithm based on the concept of message passing between data points. Unlike clustering algorithms such as k-means or k-medoids, affinity propagation does not require the number of clusters to be determined or estimated before running the algorithm. I actually don't know what you classify as machine learning. I mean, like reinforcement learning is, for example, way different than like neural networks. And so, like, you could argue in some sense that this is somehow related to, like, it depends on how you want to define this. But I don't really have a good definition of what counts and doesn't count as machine learning here. But it's certainly not neural networks in the traditional sense. Lifelong reinforcement learning via temporal logic formulas and reward mechanisms, software engineering for responsible AI, and empirical study and operationalized patterns. This one's like one of those like CS papers that you kind of want to read because it's like, oh, this could be interesting, but like, I don't want to go into it, 3D lip event detection via interframe motion divergence at multiple temporal resolutions. Is this just like reading people's lips? No, the lip is a dominant dynamic facial unit when a person is speaking, of course. Detecting lip events is beneficial to speech analysis and supporting for the hearing impaired. Again, that could be useful, not could be useful, it is useful, more useful than anything I'm doing. But I don't know if it's going to be pattern recognition in the end, which again is probably going to be another application of machine learning. Again, everything's so heavily machine learning inspired now. That's just how it goes. Sorry, my wife was just leaving, so I just want to say, bye, have a good day, that type of thing. You can check the data at the start. You check the data at the start, right? Okay. So novel optimized asynchronous federated learning framework, attacking deep learning AI hardware with a universal adversarial perturbation, data-driven discovery of Bockland transforms, and soliton evolution equations via deep neural network learning schemes. See, this is what I'm talking about. This type of stuff makes me I'm sketched out by this type of stuff because I know you can do soliton evolution like super easily with PDE solving, So why are you putting specifically deep neural networks in there? I don't know. It makes me a bit worried, Reference-based magnetic resonance image reconstruction using texture transform. Oh, that could be interesting. Developing a machine learning algorithm-based classification models for detection of high-energy gamma particles. Motion distortion correction of point clouds from oscillating scanning LiDARs. Dynamically pruning segformer for efficient semantic segmentation. Okay, look, I don't actually know what that one is. Blind VQA 360-degree video via progressively learning from pixels, frames, and video. Visual quality assessment. Maybe. I mean, look, I as much as I don't like using machine learning, pattern recognition, this kind of stuff, that could actually be quite useful for the photomosaic stuff that we're doing right now. On clustering with discounts. Okay. What does that mean? You just go to your local Walmart and you're like, oh yeah, I'd like a clustering, and here's I'd like a cluster, and here's my coupon to go with that cluster. Assessing social determinant related performance bias on machine learning models. How much do language models copy their training data? See, what I would love is a Let's Learn Monte Carlo. I mean, Monte Carlo is not particularly difficult to learn, right? What is ILUT? What is ILUT? I should remember this. Lower upper triangular. Smoothers for hybrid CAMG with scalar triangular factors. RAA net. I'm just going to skip through the computer vision, pattern recognitions, and machine learning papers. Evaluating cybersecurity risks of cooperative ramp merging in mixed traffic environments. Visiting NLI-based models. Computation and language, really, for inconsistency detection and summarization. Blockchain interoperability, triple attention network structure for movie QA, DeepGuard, the prominence of artificial intelligence in COVID-19. Ooh, now that one's probably interesting. See, I'm hoping that one is like a discussion of how we're using too much machine learning nowadays. That would be quite nice. Clustering with discount sounds like one of those ridiculous math puzzles. Deep learning again, probably more deep learning. Computation language. Actually, we're getting some good computation language papers today. Accelerated quantized GNN via GPU tensor core. GNN, what is GNN again? Graph neural network. Oh, that's almost interesting. Let me take a look at it. I'm going to read through the abstracts. Continuous learning of spiked networks and training with local rules. Okay, so here's the thing. I am curious. So you obviously see way fewer genetic algorithms papers recently as compared to probably 10, 15 years ago, but it's still interesting when you see something like that appear. So adaptive shrink mask for text detection. Actually, this one could be interesting because I was talking about using some affine maps earlier. This might be doing exactly that and doing an optimization on top of it. Artificial intelligence, machine learning, computer vision, computation and language, automatic expansion and retargeting of Arabic offensive language training. How emotionally stable. The title of this paper is How Emotionally Stable is Albert? Testing robustness with stochastic weight averaging on a sentiment analysis task. Okay. Information theory on generalized Galois cyclic orbit flag codes. So I should know way more about the information theory, specifically Galois groups. I know nothing about these and I should learn about them. I probably will learn about them soon. Ooh, that was a mistake. Let me go back. Okay. To argument or not to argument, comparative study on text augmentation languages, techniques for low resource NLP, simple track, computer vision, cryptography, and security. Here, leveraging code similarities and user feedback for effective taint specification interface for JavaScript. I think am I pronouncing Galois wrong? I thought it was Galois. Maybe I am pronouncing it incorrectly. Galois. I thought that's how I was pronouncing it. Oh yeah. Okay, I'm sorry. I knew the correct pronunciation. I might have just said it wrong. I'm sorry about that. Enhancing the insertion of NLP instructions to obfuscate malware via deep reinforcement learning, parabolic interface reconstruction for 2D volumes for fluid methods. This one could be interesting. Cryptography and security, Pell hyperbolas, DLP-based crypto systems. Let's see. Seeking common but distinguishing differences, a joint aspect-based sentiment analysis model, automatic neural network pruning, evaluating transformers for lightweight action recognition. Could be interesting, but I'm sure it's just like another machine learning application. Towards intelligibility-oriented audiovisual speech enhancement. What? Okay. Back swimmer, back swimmer inspired miniature robot with buoyancy auto regulation through controlled nucleation and release microbubbles. See, this is why I always go to CS New. There's a bunch of stuff that we have to like kind of search through, but eventually you find one like this, and I'm like, okay, I'm interested. What is this one about? You know, I wouldn't ordinarily just go to robotics, but here we are. It's like, oh, that actually seems kind of interesting. Case study for optimization of platooning coordination. What is platooning coordination? Visual navigation using sparse optical flow times transit. Let's see, computational complexity. Like, here's the thing. I used to, like maybe 10 years ago. Now, I used to look at the complexity papers and I'd be like, oh, this is quite interesting. But nowadays, I just feel like, I'm not saying complexity is irrelevant in 2021. It's obviously still incredibly useful. But man, like, it is incredibly misleading a lot of times, because you can find something that's like relatively good complexity wise, and then it ends up being like just absolutely awful benchmark wise, you know, like specifically on parallel computing devices. Like a lot of the, you know, sure, you have to do n operations, but doing n operations is way slower or way faster depending on what those operations are in parallel, right? Actually, what I should do, and what I haven't done before, even though I read a lot of parallel computing methods, I haven't actually looked at any like appropriate notation to like describe like parallel operations in the same way that big O notation does, you know, complexity theory does for CPU-based operations, you know? I feel like there should be something out there, but I'm not sure what exactly to look at, you know? Let me get some more water. Okay. Again, I'm going to start skipping through. This is one of those things that it's just kind of slow to do on stream. But usually it takes like maybe an hour or so to do it every morning. And I just kind of wanted to do it on stream here, just so you guys can see what I typically do in the mornings. So let's see, low cost, easy to manufacture, flexible, multi-taxile tactile sensor and its applications to in-hand object recognition. I didn't realize that in-hand object recognition was different than any other type of object recognition. On the recoverable traveling salesman problem, maybe that one's interesting. Subject self-distillation of uncertainty. Feature selection in NBA outcome prediction through deep learning. This is basketball in the middle of your computer science. That's interesting. Authentication of optical physical unclonable functions based on single pixel detection. You only sample almost once. Linear cost attention, self-attention via Bernoulli sampling. I don't know what Bernoulli sampling is. Should I? Maybe I should. 1 second. Okay. Strong integral input to state stability property in dynamical flow networks. Measuring source code conciseness across programming languages and compression. Okay, so here's the thing. A while ago, I don't know how to put this, but a while ago, I found this paper that was just ridiculous. It was like one of the, basically they said that a decent measure of chaos in dynamical systems is literally just converting the trajectory of the particles in the system to JPEG or PNG and seeing how big the file is. And it's like, well, that's a good, you know, order of magnitude estimate of how chaotic your system is. And I'm like, well, okay, but like, there are way better ways to do that. But my advisor at the time was like, oh, this is quite interesting. I'm like, is it though? Like, they literally just wrote an image. Like, that's all they did. And they checked the file size of the image. I don't know. I just thought it was kind of funny. Just because the reason they got away with that is because obviously the conversion of like a graphic into an image is like a very like optimized problem. So by leveraging that optimized problem, they can more easily like use like they can just get fast computation out, you know. It's a neat way to estimate it. It might be easier than the correct way. Right, that's the thing. I think it is easier. And in fact, it might actually be more correct. Like, it might give you results faster than the correct way, you know. Human-computer interaction, a co-design approach for rehabilitation, robot coach for physical rehabilitation based on the error classification of motor errors. Let's see, what do we have here? Perceiving and modeling density is all you need for image dehazing. Oh, okay. Clip cap, a clip prefix for image captioning. bibliometric analysis of the BPM conference using computational data analytics. What is a BPM conference? I should know, shouldn't I? But I don't. Learning ultrasound scanning, let's see, computer vision, machine learning, neural and evolutionary computing, machine learning, hardware architecture, having distance tolerant content addressable memory for approximate matching applications. Okay. The way to my heart is through contrastive learning, remote photoplethysmography from unlabeled video. What is photoplethysmography? Photoplethysmography. What is that? Detecting cross-language plagiarism using open knowledge graph. Self-consistent field iteration for p-spectral clustering, hybrid superintelligence, and polymetric analysis. It's literally defined in the abstract. The measurement of blood volume changes from observations of a person's face or skin. Interesting. Yeah, okay. Hybrid superintelligence of polymetric analysis, untangling circular drawings, algorithms, and complexity. That one could be interesting. Complex terrain navigation via model error prediction, transformers S2A, wiggling weights to improve the robustness of classifiers, DIVA datasets derivative of learning task, computer science and game theory, multi-channel Bayesian persuasion, supporting undotted Arabic with pre-trained language models, unsupervised learning, survey generalization, deep reinforcement learning, boosting supervised learning. Let's see, artificial intelligence, machine learning, computation, and language. Databases could be interesting. Improving prediction-based lossy compression dramatically via ratio quality modeling. Prediction-based lossy compression dramatically via ratio quality modeling. Maybe we'll take a look at that one. Identification of the source for full parabolic equations, parametricity features and their requirements. Could be interesting. I'm not sure if we want to look at the abstract. In this note, we discuss a number of parametricity features and what their requirements are in terms of complexity of the type of system and its model. It's like maybe not. Machine learning assisted approach, merging models with Fisher weighted averaging, transmits mix attended to mix for vision transformers. Interesting. Error analysis for the first time into a threshold value for partial differential equations. Let's see. Machine learning, software engineering, a method for representing an exponent in a fifth dimensional hypercomplex number system using a hypercomplex computing software. Okay, you got my attention. That's interesting. Hey Sid Long, how are you? I hope you're having a great day. Squid 3. What is Squid 3? Let me see. Okay, let's keep going. The effects of learning in morphology, of morphologically evolving robot systems, the power of selecting key blocks with local pre-ranking for long documentation information retrieval, computational engineering, finance, and science, higher order differential equation based wall distance solver. Wall distance solver, a computationally efficient high order solver, is developed to compute the wall distances, which are typically used for turbulence modeling, peripheral flow simulations, computer-aided design. This could actually be quite cool, depending on how it's done. Let's see, data-driven synthesis, computer vision, cryptography. Both of these could be cool. Nope. One-shot generative domain adaptation. Let's see, Swin Transformer V2, assisted robot reward design, optimal simple regret, and Bayesian best arm identification. Computer vision. These are just cross lists. Might be interesting, but maybe not. So shifted Brownian fluctuations game actually could be. Consensus-based distributed optimization enhancement by integral feedback. BloomNet. When people start talking about Bloom, I think of Bloom filters, and I'm like, maybe. I hope that hypercomplex paper is about octonions. I love octonions. Oh wait, octonions? Is that what we're talking about? Octonions or octonions? It's probably octonions, right? Context judgment and detection, large-scale building height retrieval, order recognition by Schubert polynomials generated by optical near field, information theoretic formulation of dynamical systems, exploring airline gate scheduling optimization using quantum computers. Okay, you got my interest in there, or you got my attention. Comparative study on how neural networks enhance quantum state tomography, certified random number generator for quantum steering, park and ride facility location under nested logit demand function. May be interesting, but I'm not going to click on it. That one I'm not going to click on just because it's too much math. Modular 1D CNN architecture for real-time digital pre-distortion, recurrent variational network, control strategies for transport networks under demand uncertainty, radar-aided 6G beam detection. I think we saw this up above, didn't we? 6G beam detection. What is a 6G beam? Is this like, I mean, maybe it's a step up from 5G, but I think it's actually something else entirely. Discrete analysis of Schwartz waveform, casting graph isomorphism as a point set registration problem using simplex embedding and sampling, visual design intuition, learning free surface flow with physics-informed neural network. Man, these physics-informed neural networks are becoming super popular as of late, and it's a question as to, like, should we actually delve into them? Should we learn more about them? I don't know. Okay. Trainable spectral development of Navi-C on the existence of co-products in the categories of Q-metroids, from optimality to robustness, C-side clustering with variational autoencoding, near-optimal quantum algorithms for multivariate mean estimation, Monte Carlo sampling of realistic counterfactual explanations. What? Monte Carlo sampling of realistic counterfactual explanations. Well, let's see what that one is. Okay, so the rest are just replacements. Causal forecasting generation, bounded autoregressive models, a low-level instruction set, architecture for hybrid quantum classical programs, and a quantum internet. Right. Well, I learned a lot there. Usually during every day, again, I spend like maybe an hour just going through archive papers, seeing if there's anything here that's interesting. Sometimes I spend longer, sometimes I spend shorter time just kind of looking at what's available. And as you can see, I usually find like 10 or 20 that I'm like, ooh, I'd love to read this, you know, and see what it has to say. Now, we aren't going to be reading any on stream. I just thought it might be interesting for some people just to see like how much stuff there is. And like for me, like you saw, I kind of just started skipping all of the machine learning papers just because there's so many of them. And it's like, I don't know, I don't really find the machine learning papers to be too incredibly like entertaining. They're fine, but it's just not my cup of tea, right? And so, you know, when you start seeing a whole bunch of machine learning applications and utilities for this and that, it just all kind of feels the same. And so for that reason, I tend to not click on those so much. But let's go ahead and see what we actually found today. So I'm probably going to read through the abstracts of all the ones that we did click on, which I would argue was probably about 10% of the actual papers that came out today. And now, again, this is the archive. These are not actual papers. These are preprints. It means that they haven't undergone peer review yet. But hey, you know, like it's a step in that direction. Okay. So towards intelligibility-oriented audiovisual speech enhancement. So I think this one was interesting because I was actually interested in what they're going to do here. It kind of is related to algorithmic composition in a way, which is another area that I have like, you know, a little interest in, which is the generation of music via purely automated means. I've always been kind of interested in this. I started looking it up when Vocaloids became quite popular a few years ago. And since then, I've always been kind of interested in, you know, the generation of music from purely algorithmic means, you know. Okay, so existing deep learning based speech enhancement approaches are generally optimized to minimize the distance between clean and enhanced speech features. These often result in improved speech quality. However, they suffer from a lack of generalization and may not deliver the required speech intelligibility in real noisy situations. In an attempt to address these challenges, researchers have explored intelligibility-oriented loss functions and integration of audiovisual information for more robust speech enhancement. In this paper, we introduced deep learning-based IOSE algorithms exploiting AV information, which is a novel and previously unexplored research direction. Specifically, we present a fully convolutional AV-SE model that uses a modified short-term objective intelligibility metric as a training cost function. To the best of our knowledge, this is the first work that exploits the integration of AV modalities with an IO-based loss function for SE. Comparative experimental results demonstrate that our proposed IO-AV-SE framework, that's a term, outperforms audio-only and AV models trained with conventional or distance-based loss functions in terms of standard objective evaluation measures when dealing with unseen speakers and noises. So I was hoping, you know how like some top streamers, like, you know, people will give them a donation and the donation is read aloud via like some sort of like text to speech thing. I was hoping this would kind of hit on that as well, but I don't think it did. Amused aloud that a preprint paper is by default about as trustworthy as a blog post. Might be just flat wrong, might have some really good deep cut insights. You really roll the dice. Yeah, I think it is something like that. I think it's probably better than a blog post. It's a little bit more trustworthy than a blog post. But some people do use the archive in that way. It's like, hey, here's a new thing. It's not fully tested yet, but this is kind of the direction that our research group is going. And that's also interesting, right? The reason I say it's a bit more than a blog post is because you don't know like who's making blog posts, right? It could be like an anti-vaxxer, or it could be like, you know, literally a medical doctor who has helped deliver the first COVID vaccines or something, and they could both be writing blog posts about COVID, right? And you know, you have no way of telling really whether the person has the appropriate credentials to make the blog post. But here, you know, at the very least, specifically if there's a group of names here, you can click the names and it's easier to just kind of check to see if just check to see if these are actual researchers or not. I don't know why you read this paper abstract, given that you were looking at color quantization and galaxy stuff. Yeah, so I actually want to spend just a little bit of time today just going through the latest archive stuff. So I'm going to start doing the color quantization and stuff soon. I just want to take a second just to look at the archive stuff because I hadn't done it yet today. I usually do this off the stream, but I just wanted to do it on stream because I thought it was interesting. Clearly, there aren't too many people that find it interesting, though, considering, you know, we don't have too many people watching. But again, if you guys have questions about any of these papers, feel free to watch, or feel free to ask whatever questions you have. Okay. So this one I thought was interesting. I want to take a look at the PDF. Specifically, I want to look at the images in the PDF here. It is a robotic... It's like a robotics paper, but it talks about miniature robot with buoyancy auto-regulation through controlled nucleation and release of microbubbles. I'm like, that sounds interesting, right? So let's take a look and see what we have here. Ocular, let's go to downloads, 2111.096. There we go. Right, so we have bubble nucleation. Okay, images were at least reproduced with permission. What I'm looking for is their actual... Are these? Oh, this is their actual design. Okay. Interesting. Pixar didn't happen. Well, I just wanted to see what their design was here. Like, what is this useful for? What's the point here? I just want to see, like, you know, obviously they're using some sort of PID software to, you know, allow the guy to swim better. I mean, it looks like a legitimate paper. I mean, they clearly did it in Microsoft Word, and it's going to be, I don't know what they're submitting it to, maybe an IEEE journal. Bubble release mechanism through linear mechanical vibrations. The cellular 3D printed canopy linearly oscillates to release surface anchoring bubbles. Okay, interesting. Cool. Okay, so they're kind of using this to... So I think what they're doing is they're like pushing a bubble up, and then the bubbles will go through the surface to kind of create like a wiggling effect in order to make it swim. I assume that this is useful for his disaster recovery and rescue efforts. Could be. But this thing has to be super small in order to use the surface tension of bubbles in order to make it swim. But here it is, right? Here's working. So we have in C, 4 stages in the auto-regulation of the back bot buoyancy. The initial stationary say bubble nucleation and growth through catalytic activity, resulting in movement upward, controlled release of bubbles in order to achieve the force balance, and further release of bubbles to reverse the forces resting in descending of the robot. So are they just like making the robot really hot in order to like create a bubble and then having the bubble make the thing float? That's actually quite cool. Like, I don't know, it's a neat thing. I don't know what it's useful for, but it's quite neat. Let me go here, remove. So on recoverable traveling salesman problem. Yeah, so I didn't know what a recoverable traveling salesman problem was. So in this paper, we consider a recoverable traveling salesman problem. Here, the task is to find two tours simultaneously such that the intersection between the tours is at least a given minimum size. Well, the sum of the travel distance with respect to the two different distance metrics is minimized. Building upon the classic double tree method, we derive a 4 approximation algorithm for the recoverable TSP. We also show that if the required size of the intersection between the tours is a constant, a 2 approximation guarantee can be achieved. Even if more than 2 tours need to be constructed, we discuss consequences for approximability results in more general area of recoverable robust optimization. I'm not sure what they mean by recoverable still. Let me open the PDF. Okay. 9691. Let's see. Out of curiosity, how many archive papers do you skim through per week? Over 100. Like, I mean, I seriously go through like at least 20 a day. I mean, I go through a lot. You know, I say at least 20 a day. 20 times 7 is clearly not less than, what is that? 20, that's 14. So it's over 140. So, but probably about 100 is about right. So it's not new. It's actually genuinely interesting. Like, you know, I had no idea what a recoverable traveling salesman problem was before today. And here I am learning something. I still don't know what it is, but the fact that it exists might appear later. Like, it's one of those things where, like, you know, this stuff is super interesting because, like, it appears, and you can stop whenever you want, right? Some of that is true. I know I'm a little bit addicted to academic articles. Like, I find them super engaging. So it's kind of like, there were some times, like during the PhD, where I specifically had to stop looking at the archive daily because I got too addicted to it. Like, every single day I was printing out, like, you know, 5 or 10 papers, and like I literally had a stack of papers that was like 2 meters tall. Like, you know, I just had an insane number of papers that I had published by the end of my PhD. I say 2 meters, but it was probably only 1 meter tall in the end. But it was really, really high. Like, it filled up the entire desk. It was insane. And so, yeah, I mean, at some stage I realized, like, I really need to cut back and stop reading so much and actually get real work done. But, you know, the days when I could just sit back and read papers, like those were my favorite days. I love just like sitting and trying to understand papers. This one's a bit too mathy for me. I'm not entirely sure. Let me try to reread their paper again. So a recoverable traveling salesman is to find 2 tours simultaneously such that the intersection between the tours is at least a given minimum size. Well, the sum of the distances with respect to the two different distance metrics is minimized. So let me see if I can think about this a bit. So let me go here. Journal, new page before. So for those of you guys who may not know, I'm sure a lot of people do, the traveling salesman problem, you have like a group of, you know, points here, right? And the traveling salesman problem is that you have a guy who needs to visit all of these points, but also minimize the distance in which this guy travels. So the recoverable traveling salesman problem says you have 2 guys, and the intersection, and I don't know what's defined as the intersection, but the intersection between their 2 paths, the intersection between their 2 paths is at least a given minimum size. So that means that I think the 2 of them together traverse the entire graph, and then you minimize their total distance. But why is that recoverable? I'm wondering what the intersection. Yeah, I don't know what they mean by intersection. Let me see if I can just Control F, intersection. Here, yep. We also show that if the required size of the intersection between the tours is constant, a 2 approximation guarantee can be achieved. Even more. Let me see if they just give me it. What I'm really trying to figure out is, what does recoverable mean? Okay, so we introduce the idea let's see, which was introduced in the area of recoverable robust optimization. 4, let's take a look at 4. This is going to be on the recoverable robust traveling salesman problem, 2016. Let me just see if we find this really quick. Here we go. Let me just go to Scholar here. I just want to figure out what recoverable means. We consider an uncertain traveling salesman problem where distances between the nodes are not known exactly, but may stem from an uncertainty set of possible scenarios. This uncertainty set is given as intervals with an additional bound on the number of distances that may deviate from their expected nominal values. A recoverable robust model is proposed that allows a tour to change a bounded number of edges once the scenario becomes known. Okay. So the issue here is you don't know the distance between each point here. So you don't know how far away these guys are, for example. And so what you'll do is you have two separate travelers who have some number of nodes that they travel together. And then the idea is that these guys will then fully, concretely define the distance between the points. And this allows for you to create an optimal traveler around the points by traversing the grid twice first, if that makes sense. So you have two separate paths, and then you use the knowledge that you gain from those two separate paths in order to recover the actual best optimal path once you know this distance d, right, or something like that. I think is what we're doing here. I might be wrong, but that's kind of what my guess is. D here. Let's just keep looking at the other ones for now. D. Untangling circular drawings, algorithms, and complexity. Yeah, I was interested in this one. Untangling circular drawings. What does that mean? What is a circular drawing? We consider the problem of untangling a given non-planar straight line drawing a circular drawing of an outer planar graph into a planar straight line circular drawing by shifting a minimum number of vertices to a new position on the circle. For an outer planar graph G, it is clear that such a crossing-free circular drawing always exists, and we define a circular shifting number, shift delta G, as the minimum number of vertices that are required to be shifted in order to resolve all crossings delta G. We show that the problem circular untangling asks whether shift delta G less than K for a given integer K is NP complete. Ooh. I think I'm not going to be able to understand this one even if I do read it, so I might go ahead and skip it for now. Improving prediction-based lossy compression dramatically via ratio quality modeling. Right, so this one was interesting because I'm always interested in lossy compression. Error-bounded lossy compression is one of the most effective techniques for scientific data reduction, of course. However, the traditional trial and error approach used to configure lossy compressors for finding the optimal trade-off between reconstructed data quality and compression ratio is prohibitively expensive. That is also true. To resolve this issue, we develop a general-purpose analytical ratio quality model based on the prediction-based lossy compression framework, which can effectively foresee the reduced data quality and compression ratio, as well as the impact of the lossy compressed data on post hoc analysis quality. Our analytical model significantly improves the prediction-based lossy compression in 3 use cases. 1, the optimization of predictor by selecting the best fit predictor, memory compression with a target ratio, and in situ compression optimization by fine-grained error-bound tuning of various data partitions. We evaluate our analytical model in 10 scientific datasets, interesting, demonstrating its high accuracy, 93.47 accuracy on average, which actually isn't too high for scientific applications, but that's fine, and low computational cost, 18.7x lower than the trial and error approach. For estimating the compression ratio and the impact of lossy compression on the post-hoc analysis quality, we also verified the high efficiency of our ratio quality model using different applications across the 3 use cases. In addition, the experiment demonstrates that our modeling-based approach reduces the time to store the 3D reverse time migration data by up to 3.4x over the traditional solution using a 128-core CPU from 8 compute nodes. Interesting. This is one of those that I'm glad to have read. I'm glad I know exists, but I'm probably not going to be spending time to look into. In fact, I'm not going to be reading any of these on stream. I just kind of wanted to look at them, to see what exists, So the method for representing an exponent with a fifth-dimensional hypercomplex number system using a hypercomplex computing software. So the reason I was interested in this one is because all the way up here, this seemed like an interesting paper. Then all of a sudden, using a hypercomplex computing software, I'm like, wait, what? What are you talking about? The structure of a method for constructing a representation of an exponential function in hypercomplex number systems by the method of solving an associated system of linear differential equations is considered. Brief information about the hypercomplex computing software HCS is given. Okay, so they built HCS. That's what happened. With the use of HCS, the necessary cumbersome operations on symbolic expressions were performed when constructing the representation of the exponent in the fifth dimensional hypercomplex number systems. This is interesting. Fragments from the programs in the environment of HCS and results of the symbolic calculations are resulted. I actually want to take a look at this PDF. This is interesting. Anytime they talk about symbolic computation, I'm like, oh, okay. Yeah, this could be cool. Let's see what we got here. So let's do ocular. Oh, I think I already have a terminal up. Let's just delete that one. There. And this one is 9841. Ooh, okay. I'm not particularly happy with their formatting here. I was hoping for some benchmarks, but I don't think they're giving us any benchmarks. No, I see no benchmarks here. I really want to see some benchmarks, but they're symbolic computation. But they didn't give any. I'm probably not going to read through that paper. All right, let's keep going. Okay, next. I wrote a differential equation based wall distance solver. Right. So I was interested in the wall distance solver. So for like PDEs, this type of stuff, finding the distance to the wall where you typically have to do some sort of boundary condition, it can be quite interesting. And so if that's what this is doing, then this could be a really interesting paper that leads to a bunch of interesting results. Let's see. A computationally efficient high-order solver is developed to compute the wall distances, which are typically used for turbulence modeling, right? Peripheral flow simulations, computer-aided design, etc. The wall distances are computed by solving the differential equations, namely Eikonel, Hamilton, Jacobi, and Poisson. The computational benefit of using high-order schemes for wall distance solvers, both in terms of accuracy and computational time, has been demonstrated. The new Hamilton-Jacobi formulation, based on the localized artificial diffusivity approach, has been proposed, which has produced results with an accuracy comparable to that of the Eikonel formulation. When compared to the baseline Hamilton-Jacobi solver using upwind schemes, the solution accuracy has been improved by an order of magnitude, and the calculations are roughly 5 times faster using the modified HJ formulation. Yeah, I get the same feeling when it comes to fluid dynamics. I was hoping for something a bit, but I mean, the thing is, when people talk about PDE solvers, they almost always go fluid dynamics. That's just what they do. I'm not saying that's what they should do. It's just that it's a reasonably clicky area to talk about PDE solving with. A modified curvature correction has also been implemented in the HJ solver. Frankly, probably not a paper I want to read. Brownian fluctuation game. This article analyzes the behavior of a Brownian fluctuation process under mixed strategic game setup. A variant of compound Brownian motion has been newly proposed as called sifted Brownian fluctuation process. Shifted, typo, to predict turning points of a stochastic process. The shifted Brownian fluctuation game has been constructed based on this new process to find the optimal moment of actions. Analytically tractable results are obtained by using the fluctuation theory and mixed strategy game theory. Okay, this could be interesting. I'm happy to see it exists. It's something that I'm a lot of times when it comes to the archive papers, what I do is I kind of as I'm reading other research, I'm all of a sudden oh yeah, I remember this archive paper from a few years ago. Where was it? And then I end up looking for it, that type of thing. So it's one of those it's good just to at least read the headlines. So this was an interesting one. Exploring airline gate scheduling optimization using quantum computers. What? This paper investigates the application of quantum computing technology to airline gate scheduling quadratic assignment problems. Right. Okay. We explore the quantum computing hardware architecture and software environment required for porting classical versions of these types of problems to quantum computers. We discuss the variational quantum eigensolver in the inclusion of space-efficient graph coloring to the quadratic unconstrained binary optimization. These enhanced quantum computing algorithms are tested with an 8-gate and 24 flight test case using both the IBM quantum computing simulator and the 27-qubit superconducting Transmon IBM quantum computing hardware platform. Interesting. So what's interesting about this is I actually don't know of too many. I should know. Again, I've been a bit behind recently. But I actually don't know too many places that are using quantum computing to, I've seen, oh, sorry, I hit the microphone. I've actually seen quite a few places now that I think about it that have used quantum computing for optimization methods. It's weird to see it for airline gate scheduling. I never saw it in such an applied problem, you know? Okay, Monte Carlo sampling of realistic counterfactual explanation. Okay, so this one was interesting because I wanted to know what they meant by counterfactual explanations. I was like, well, does that mean like Tucker Carlson coming on and saying like, you know, we should like saying something that's obviously wrong? Or, you know, what does this mean, right? 1 second, let me check. Something, I just got a notification. Perfect, okay. In this paper, we introduce MCCE, Monte Carlo sampling of realistic counterfactual explanations, a model-based method that generates counterfactual explanations by producing a set of feasible examples using conditional inference trees. So this is about creating lies. Interesting. Unlike algorithmic-based counterfactual methods that have to solve complex optimization problems or other model-based methods, that model data and data distribution, distribution using heavy machine learning models, MCCE is made up of only 2 lightweight steps, generation and post-processing. MCCE is also straightforward for the end user to understand and implement, handles any type of predictive model and type of feature, takes into account actionability constraints when generating the counterfactual explanations, and generates as many counterfactual explanations as needed. In this paper, we introduce MCCE and give a comprehensive list of performance metrics that can be used to compare counterfactual explanations. We also compare MCCE with a range of state-of-the-art methods and a new baseline method on benchmark datasets. MCCE outperforms all model-based methods with most algorithmic-based methods when also taking into account validity and actionable constraints. Finally, we show that MCCE has the strength of performing almost as well when given just a small subset of training data. Interesting. I have discovered the internet-published academic journal about fandom, transformative works and cultures itself has enough of a fandom that fans have made full PDFs of each issue, apparently prompting the journal to start doing it themselves. Interesting. This is ridiculously meta, and I love it. That's super cool. So I think if I read this correctly, this is literally about creating creating believable lies. Like, am I reading that correctly? Am I understanding what this is? 1 second. I think I can just go there. Yeah, okay. So ocular downloads 2111 97. Optimization algorithmic based. This is actually quite cool. If this is what I think it is, I'm actually really excited about it. But it might not be exactly what I think it is. But yeah, like creating an algorithm that can just lie to you all the time, I don't know, I find that really cool. Okay, close that. Remove all finished, D here. Okay, blind VQA on 360 video. Let's see. So this one I was just interested because of the photomosaic stuff, but I might just go ahead and skip this one for now. Accelerating quantized GNN via GPU tensor core. Again, I was interested in the GPU stuff, but I think I might not look at this in too much detail. Adaptive shrink mask for text detection. Okay, so this one I was interested to see if they do like an affine mapping or something else. That's why I wanted to look into this one. So existing real-time text detectors reconstruct text contours by shrink masks directly, which simplifies the framework and can make the model run fast. However, the strong dependence on predicted shrink masks leads to unstable detection results. Moreover, the discrimination of shrink masks is a pixel-wise prediction task. Okay, I want to take a look at this PDF because I think what they're doing is they're trying to predict text via an affine mapping, I think is what they're trying to do here. But let me double check. CD downloads. Gibbous. Also, the journal is just neat in concept for producing things like a paper about heteronormative romance tropes in Harry Potter fan fiction. Interesting. I mean, yeah. It's very social sciences though, so I recall it's well out of your wheelhouse. Yeah, that's probably fair. Okay, so let me do ocular, and it's 2111, and we're looking at 95. Sorry about that. What I'm looking for, yes, that's exactly what I thought it was. Super cool. Okay. Yeah, so they're literally just trying to recognize text. Good. I'm happy to see that this exists, because this is something I was going to look into in the near distant future for ASCII text recognition anyway. So I'm happy to see that exists, and that is something that we can look into. Cryogenic memory technologies. Okay, I just didn't know what a cryogenic memory technology was, so I decided to click on this one. The surging interest in quantum computing, space electronics, and superconducting circuits has led to new recent developments in cryogenic data storage technology. Quantum computers and superconducting single-flux quantum electronics promise the ability to solve the challenges, such as currently unsolvable problems and speed power issues faced by their conventional and semiconductor counterparts, respectively. But one of the major bottlenecks for implementing scalable quantum computers and practical SFQ, what is SFQ again? Single flux quantum circuits, is to find suitable and compatible cryogenic memory that can operate at 4 Kelvin. Right. Clearly this is an issue, right? Because, so, I don't know if this is true anymore, but at least when I started the PhD, there was no such thing as like a universal quantum computer. There were like IBM quantum computers, but these only have like nearest neighbor qubits to deal with and stuff like that. So to have a universal quantum computer where qubits can entangle across the distribution wasn't possible, which is why you need like cold atoms, which exist at like 4 Kelvin, or maybe photonic systems that require a vacuum, like this type of stuff. And so having memory that can work in this at these temperatures and at these scales is super important, and that's what this is for. So local mutual exclusion for dynamic anonymous bounded memory passage. This is another one that I'd probably read through, but I probably don't have time to do it right now. The reason I was interested was the message passing systems. So local mutual exclusion for dynamic anonymous and bounded. So the idea here is that we can create a network of like kind of information processing that's done on distributed systems. So I thought that was kind of interesting. 1 second, what do we have here? So towards open vocabulary object detection without human-provided bounding boxes. Again, I was interested in this one for various reasons, because I'm always interested in like vocabulary detection and stuff like that. But I'll skip it for now. Novel grid-forming voltage control strategy for supplying unbalanced microgrid loads using inverter-based resources. This one I was interested in just because I wanted to take a look at it, make sure that we make sure that I understand it for the electrical engineering project I was thinking about doing. Transition power policies, again, for a similar reason. Okay, I just read the abstract. Personally federated learning through local memorization. Probably don't want to do that. That's probably more machine learning. Hypercontractivity on high-dimensional expanders. So this one I came up twice. I didn't know what hypercontractivity was. So we provide hypercontractive inequalities on high-dimensional expanders, as in the settings of the p-biased hypercube, the symmetric group, and the Grassmann scheme. Our inequalities are effective for global functions, which are functions that are not significantly affected by restrictions of a small set of coordinates. As applications, we obtain Fourier concentration, small set expansion, and Kruskal-Katona theorems for high-dimensional expanders. Our techniques rely on new approximate Efron-Stein decomposition for high-dimensional link expansions. All right, I don't think that's super useful. So this one I was like, why do you need 60 pose estimation? What is your other 3 dimensions here? I'm getting way too distracted by my own pure binge re-fandom studies, so I'm gonna hop off. Yeah, have a good afternoon or morning. Thanks for stopping by. Object pose estimation has multiple important applications, such as robotic grasping and augmented reality, represent a new method to estimate the 6D pose of objects that improves upon the accuracy of the current proposals and can still be used in real time. Our method has RGBD data as input into segment objects and estimate their poses. It uses neural network with multiple heads. One head estimates the object classification and generates a mask. The second estimates the values of the translation vector, and the last head estimates the values of the quaternion that represents. Okay, I see. That's, I think it's 60. Hybrid feedback for autonomous navigation in environments with arbitrary convex obstacles. Again, this is one of those things, like, it's probably a PID system. I thought was quite interesting as we stopped by. Distributed proximal policy optimization for contention-based spectrum access. The distributed proximal policy optimization is what I was interested there. Stream sampling with immediate decision. The manuscript introduces a method to select a random sample from a stream by deciding on each sampling unit ultimately after observing it. The process could be applied to unequal as well as equal probability sampling. Unless with Punya 1, a soft tactile sensing upper body robot for large object manipulation, physical human interaction. Interesting. They're talking about, like, literally having a robot that has, like, physical human interaction. The manipulation of large objects and the ability to safely operate in the vicinity of humans are key capabilities of a general purpose domestic robot assistant. They're literally talking about a domestic robot assistant. Okay. So this is kind of what I do in the mornings, usually before stream. It usually takes me, like, way less time to do it at home, and usually I can even print out a paper and read it. It's just that because I'm here on stream, it's quite difficult to do everything all together. You know, like, it's like I have to read through it aloud, which takes longer than just reading through it not aloud and all this kind of stuff. I'm going to be right back, and then I haven't decided what we want to do next. I actually do have a lot of papers I need to get through. So maybe I talk about, like, what we're going to do research-wise. And then I also want to go through some algorithm archive work as well. So yesterday I did a 2-hour stream. The day before that I did a 3-hour stream. I think today is going to be also probably like a 3-hour stream or something like that. We'll see how it goes. So I think next, let's talk about the research plan next. And try to get a rough timeline of what we need to do and when we need to do it. And then we can talk about, then we can start getting some papers to figure out the actual, like, structure of how we're going to, like, work on that. And then from there, we should be able to work on some algorithm archive work, hopefully around, like, maybe 5 p.m. or something like that. So that's in, like, an hour and 30 minutes. We'll see how that goes. So again, guys, I will be right back. Sorry about that. Hey, Fled from Nowhere, how are you? Give me just 1 minute and I will, yeah, I'll be back. Give me 1 minute. Okay, so we just finished going through all the archive papers from the computer science repository. Yeah, I wasn't doing any code. I had to go upstairs and do some things really quick. So I'm back. I want to talk just a little bit about, where is it? There it is. I want to talk just a little bit about, what the research plan actually is here and what we want to do. And it's good that we have people here to talk about it too, because I actually don't know. I don't know the best way to approach this is the thing. And I think it's good just to talk to people about it and see what we want to do. So let's just go and delete here. Right, so as you can see from the title, it says 4D, maybe it does. What does it say? Galaxies and colors. Okay, so the question was, what do galaxies and colors have in common? Oh no, what is this a setup for an amazing joke? No, it's not. The thing they have in common are octrees. Right. So if you're going to do color quantization, which is the act of limiting the number of colors in an image, then you have to do, or you can use color quantization, which is a type of octree-based approach where you basically split the colors into RGB space, and you say, okay, this color is mostly red and stuff like that. Now, similarly, the Barnes-Hut method is a way in which you split up space so that you can more easily represent like objects and galaxies as like one giant glob for particles that are very far away, so you don't have to deal with as many particle-to-particle interactions in an n-body system. What they have in common is L. That is correct. They have one L in common. That's it. That's the end of stream. Thanks for coming by. Okay, 1 second. So what am I going to do next? So, right. So they have octrees in common, which is something that I wanted to explore. But actually, in actuality, and this is something that I mentioned at the very start of stream, there's a lot of things that they have in common in terms of like how people solve the systems and stuff like that. You can use methods that basically work for like marking down space for color quantization. You can use that for galaxy simulators, and you can use the time-based methods for galaxy simulators to better solve like videos for color quantization and stuff like that. So this kind of interplay between color quantization, galaxy simulation is quite nice. So in particular, I talked to obviously Grant from 3 Blue 1 Brown, and we were interested in doing a 4D galaxy simulator. Right? So that was something that we were interested in doing. But the issue was like, this is where like we philosophically see things kind of differently. And like clearly he's doing better on YouTube than I am, right? Like it's very clear that he is, and no matter what I do, I'm not going to be able to really catch up to that. But I just don't want to make educational content on YouTube. Like I'm fine doing 4D galaxy simulations because that's not education anymore, that's research, right? And I'm happy to make videos like that. But I don't want to make videos where the explicit purpose is to educate people about this topic, because I just feel like any written form of content is going to be better at describing this topic than a video form, right? So for that reason, I can see like maybe one good video coming from this. And then like, he was like, oh, and then you can talk about the computational methods on your YouTube channel. But I'm like, look, I don't want to talk about the computational methods. I feel like, like the computational methods are best suited for the algorithm archive. They're best suited for a research paper. I don't want to talk about it on YouTube, And so for that reason, I was thinking maybe what we could do is he could do a video on 4D galaxy sims, and I could do maybe another video on color quantization. I don't know. So right now I'm only seeing basically one video available here, which is a 4D galaxy simulator on his channel. So it's super unfortunate, because if I go this direction, it means I won't get a video out until the new year, because this is going to take probably another 2 months to do. so that means my next video is not going to be until February, right? Is it worth putting a video on his channel to get, some sort of viewership on my channel? Maybe. But then on the other hand, it's not really a good collaboration because, it's not a good collaboration because it fundamentally means that I'm not pointing to his channel. He's only pointing to my channel, and it's just not good. It's just not a good thing to do for a collaboration. So we're still trying to figure that out and what we want to do there. But what I have been doing is doing a lot of reading into the, galaxy simulations, like Barnes Hut simulators and color quantization literature and stuff like that. And that's kind of where I've been spending a lot of my time recently. And so what I'm seeing right now, as different ways that we can approach, different things that might be interesting. One would be a adaptive mesh refinement. Oh, sorry, I'm not using. One would be, let me just go here, adaptive mesh refinement for color quantization videos. And this is where, color quantization kind of learns from the galaxy simulation. And two, we can probably do a better, color quantization methods in galaxy simulations. So these are kind of two interesting research directions that I could imagine going in. And I'm still looking at papers for both these directions. In fact, I probably will continue looking at papers in just a bit. And so that's kind of, what I'm looking at doing right now. The thing is, neither of these actually create good video content. The only good video is like a 4D galaxy sim. That's the only one I can think of. That's it. That's literally it. And for a 4D galaxy sim, we're really only talking about an end body simulator. Right. We're not going much further than that. So here's what I'm going to do. I'm going to go ahead. I've got a bit of a headache right now. It's not because I was just going through the papers. I just got a headache right now. And I haven't eaten anything yet today. So I'm going to take a break. I'm going to look at these off the stream. I might come back at 5 to do an algorithm archive stream. Otherwise, I might do it off the stream. But I've decided I think I'm going to go ahead and close stream now. I'm doing my best to make sure I do a stream every day, which I'm going to keep to. Again, I'm just trying to increase the number of streams that I do, but I'm just out of it right now. So, slowly but surely getting that stream stamina back up. And so I think this is where I'm going to close it for today. And then we're going to come back tomorrow and hopefully start writing some code down for this. So, I'm just very heavily in the literature review stage for this particular project, and it just takes time to get past that stage, Okay, so that's it for now. Thanks guys for coming in, and I will see you next time. Bye guys.